So, for anyone watching the video, you should have already started the algebra tile investigation worksheet, so I thought I'd just do a couple examples to kind of help you finish that up, okay? So the first one, we are supposed to expand out this polynomial, so you guys know that on the worksheet there's a few that'll ask you to do it by distributing. That's the most important, most efficient way. You got to be able to do it on the exam, which most of you guys did plenty fine on in the last test, in my class at least, most people. But this time we're going to do it with a picture. So I don't want to expand this by distributing this time. I'm going to draw the algebra tile picture for it. So you guys, can you help me out? How's this picture going to go based on what we did yesterday? How about 2x plus 3? How's that going to go?
About 32.
You want me to put on top, Logan?
Yeah.
I don't think it really matters, top or side, but let's go on top since Logan said that way. What should I put?
2 of the big boxes for x.
2 of the big boxes for x, okay? Those boxes, even though they're big, they're supposed to represent something that's unknown, right? Like they're just a box that's not necessarily 1. I mean, it really could be smaller, but they're supposed to be like kind of unknown size. And I'll color them blue since they're positive. What else is going to go up there?
3 little blue.
3 little blue ones. Very good. It's getting sloppier already. Tried to keep it neat, but I'm already failing. Okay, what about on the side?
Or 1 big box, blue box.
1 big blue X box, okay. And Joe?
5 red boxes.
5 red little boxes or big ones? Little ones, just 1 boxes, right? Oh god, this is getting really sloppy.
Looks better than mine.
That's not good. So luckily we don't do it this way usually, right? Because this takes a long time, but just for today. Okay, so we've got our problem set up. How do we fill it in? How do we fill in the answer portion of the algebra tile diagram?
Well, for the first one, you take both the x's that are up there, and that's going to become like a really big square. It's going to be an x squared.
Okay, so should I just maybe make a grid here real quick? So I'm not continuing to be so sloppy. It's like this, like this. Should I make these into smaller boxes?
No.
Good. And then this, should I make a ton of smaller boxes down here now, or how's that go?
Draw a straight line.
Just draw a straight line, okay. Then what?
And then
Lots of smaller boxes?
Yeah, whatever. Yeah, just draw.
No, if I tried to do this, there'd be no line up here to connect, right? So I mean, it should make sense from an artistic point of view. And over here, same thing. These are supposed to be equally long boxes. Well, they're not exactly equally long. And over here, we're going to have long boxes, short boxes.
We're going to have a ton of those.
Well, we're just going to have a little grid because of these lines coming together, right? So this is where we're going to have lots of little ones. Oh man, this is pretty awful. Okay, so now we've got to decide whether things are red or blue and what the things are. So I think that's the only part that you could mess up a little bit. So what goes here? Blue and blue makes blue. Blue and blue makes blue, but what are these? They're x squareds.
They're blue.
They're big long X boxes, right? Not Microsoft's Xbox, I'm sorry. So what about these ones?
Red.
How do you know?
Because
They could be red or blue.
Negative times positive is negative.
Negative times positive is negative. In this case, red times blue is
red.
red. So this should be a negative, not 1, but they're long ones, right? Negative X. And what about these guys? Should these guys be positive blue ones or negative red ones? Negative, because we got red and blue again. When you mix things, you get negative. When you have blue and blue, that's positive times positive is positive. Red and red. Negative times negative is positive, so that would make blue as well, okay? So these are all negative, you guys agreed. So from that, we should be able to write down our answer. Yeah? So all that stuff in there is the answer. How many x squareds? 2. So 2x squared. That's what you'd get if you multiplied these. 2x squared. How many x's? That's the part you got to think about for a second. 3 positive ones.
Yourself.
Looks like 10 negative ones, doesn't it? So -7 and +3 is -7.
-7 and +3.
Oh yeah, -10. Sorry, my bad.
That was kind of.
You guys got it? So the best way to think about this is to think about them canceling. This is the best way to think about negatives and positives, period. That's one reason I'm having you do this, because some of you still have some issues with negatives and positives, not very many people, which is good. But like, I think about this as like, these are gone. Gone. They cancel each other out. These are gone. Cancel each other out. And then you pick another one. These are gone. Cancel each other out. So you have these left. And that's 7 reds, so that's 7 negative x's. Okay? And then the reds, the other part's easy. How many of those do we have? 5 by 3 is 15, and they were negative. Okay? So that's how you do those problems. What if you have something like this? Let me do one more example. What's the problem that this is modeling, first of all? Can you guys tell me? What's the product? Kayla? X plus 3 here? Yeah, I think you've got it. You have one too many minuses, but pretty good, pretty good. So we're gonna have x plus 3 multiplied, added, multiplied. So you guys remember in this unit, sometimes we're adding polynomials. That's the easiest thing. You just put your like terms together. Sometimes we're subtracting. If you see subtract between the polynomials right here, then you should just distribute the -1. Some of you were tempted to multiply because you were thinking, I think, like, there's parentheses, so I just always multiply. That's not the case. This case, I know it's multiply because you've got like 2 sides of a box. That's obviously multiply, okay? And Kayla said, I think, -x minus 2 up there. Great. So we could, of course, do that by distributing. That's the best way to do it. So if we were going to do this, though, I'd fill it in. You guys showed me a second ago, so I'll do this one, right? Bless you.
Thank you.
So notice you can actually do that pretty quickly. If you just follow the lines.
See, that one looks neater. This one looks like.
I know. So think about the difference in how I did those. That one I kind of did it like piece by piece. This one I just followed the grid lines. So up to you how you do it. So now we got to decide red or blue. What's this thing?
Red.
Red. So we got blue and red, right?
Oh, that's.
So it's negative
It's all negative.
All gonna be red.
x squared. Is it all going to be red?
Yes.
Yeah, because it's like all totally blue and totally red. Very nice. So this is going to be what? Negative x, because it's a long box. Another one of those over here. Again, we're going to have the same thing. And over here, again, we're going to be negative. Great, so now we've got our answer. So this one is going to be negative x squared, 5 of the negative x's, and 6 of the negative 1's. Let's check that answer. That's what I want you guys to do on the back of that worksheet for all 4 is check them the faster, more efficient way without the picture. Let me check that real quick.
Negative x squared. So there's x squared, you know, in the bigger box, then there's 2 negative x is right there.
What's your question, Caden? Sorry.
So in the bigger box, there's an x squared. Is that the one that you put up in the column, or?
That's part of the answer. So all this stuff, remember, is all the answer. You've got a negative x squared. You've got 1, 2, 3, 4, 5 negative x's.
Okay.
And you've got 6 negative 1's. Yeah?
So, say that you got an equation and it wasn't just like x plus 3 or like negative x minus 2, it was an x squared. How do you do that big box up the
So if there was like an x squared in here, because
Yeah.
we've multiplied things out like that, very good question. This is what I was talking to Mary about the other day. You'd have to go to 3-dimensional algebra tiles. So that would be a 3-dimensional problem.
So aka throw a desk at it.
So yeah, like you could definitely model it, but it'd have to be 3-dimensional. And there are 3-dimensional algebra tiles, but I don't know if we're going to use them. You know, like it's pretty inefficient.
Okay, so we won't have to worry about
No. We're never going to do that. I mean, if we could, totally, but
Alright.
it'd be more trouble than it's worth if you know what I mean. Good question. It's a really good question, Sheridan. So let's check to see if that was the right answer. So here we go. These 2 things, what do I get if I multiply them?
Negative x squared.
That's the negative x squared. Good. These 2 things.
Yes, I did.
It's negative 2x. These 2 things. negative 3x, and these two things, negative times positive is negative 6. Combine your like terms. I should put an equals there too. These are like terms. There's 5 of the negative x's. Same answer. So obviously this is a lot faster, easier way to do it, but I think the visual is kind of nice. And it should help you if you're having trouble with negative numbers. So. Okay?
The visual